Hi, welcome to your fourth flip video. This is 2.0D, fractional exponents. What we have here is an example of what we're talking about today, right here. So this says the square root of 4 squared. Sounds like there's a lot of squared going on there. Now, I want to show you a way that we use this. This is not in simplest terms. A way we can write this is the number 4 squared still times another way to write the square root is 1/2. So now you see this says 4 squared like we had it times the exponent 1/2, and this radical represents the 1/2. Now if we simplify this further, you know that 2 times 1/2, 2 times 2 is 2, and 2 times nothing is 2. So now I have 4 to the first power, and the way I got that is because 2 divided by 2 is just 1. So the answer to this problem is actually 4. So what I was trying to prove to you here is that this exponent cancels out the square root. Here's our next examples. This first one, the cube root of 8 cubed. That sounds like a whole lot of repetitiveness again. Now, let's write this with exponents. This is 8 cubed. The way I got that is 8 is the base cubed. And now the radical with the cube root is represented with 1/3. Same thing is happening here like in our first example. 3 times 1 is 3, and 3 times nothing is 3. 3 divided by 3 is 1. So our answer here is just 8. Here's another one. This one, the way we read it is the square root of 144 squared. So the way we write this, our base is 144. You know that we raise it to the power of 2 times, and by now you should know that this radical is represented by the fraction. This radical is represented by the fraction 1/2. Now if we simplify that, just like before, we get 144. 2 times 1, 2 in the numerator. 2 times nothing, 2 in the denominator. So my new exponent is 1. The answer is 144. For the next problem, throw your own perfect square in there. 4, 9, 16, 25. Throw something you know in there and write it out the way we've been writing. Go ahead and do that in your notes. When I chose, after I paused, I wrote in the number 64. So the way we read this once again is the square root of 64 squared. The base is 64. We are raised to the second power, and we know that radical is represented by the fraction 1/2. 2 times 2 is 1. 2 times 2 is 2. 2 times nothing is 2. "64 to the first power is just 64. Okay. So in those first problems, it was pretty easy. Everything was just canceling each other out. Now this gets a little more complicated. This first problem says the square root of 4 to the 4th power. So let's go ahead and rewrite this. Our base stays the same, and it's raised to the 4th power. Now like we said before, this radical is the same as the exponent 1/2. Go ahead and simplify that. The base stays the same. 4 times 1 is 4. 2 times nothing is 2. Now I have 4 divided by 2 is 2. And 4 squared is 16. So that one was a little bit different because the power was different here. If that would have been a 2, it would have just canceled. Let's look at the next one. It says the cube root of 10 to the power of 6. So when we rewrite that, we write the base of 10 with an exponent of 6. And that radical, which is the cube root, is written as 1/3. And the way I got 1/3 is because there's a 3 sitting right here in the radical. So that's like our cube root. Now we keep simplifying. I have 6 times 1, which is 6. 3 in the denominator because 3 times nothing. Now I have 6 divided by 3, which is 3. Oh, hold on. 6 divided by 3, which is 2. My bad. Now I have 10 squared. 10 squared is just 100. Alright, one last example before we move on. This says the square root of 9 to the 8th power. Whoa. Okay, so 9 is our base. The exponent is 8 times this radical. When there's no numbers there, we know it's the square root. So we write it as a 1/2. When we multiply 8 times 1, we keep our base of 9 and do 8 over 2. Now you know you need to simplify 8 divided by 2, which is 4. So now we have 9 to the 4th power. When I do 9 times 9 times 9 times 9, I get 6,561. And that is your answer. We'll practice more of these in class tomorrow. Good job!